Now have the bare bones of a brick veneer overlay with our timber frame detailing. So we've added the brick wall and we've added the concrete slab slash footing, but it's pretty raw and we haven't really explained it all in context. So I want to do that now and then look at the extra little bits that we need to add for this to work practically. We don't want this concrete slab to be floating. Of course, it's not floating in midair. It needs to be sitting on the ground. And so we need to represent this in terms of its relationship with Earth. This red line out here was representing how it would sit against the ground outside. So if we were then to continue that through, let's change the color of this. Make this just a different type of brown. Now, of course, in reality on the site, this would be extending through the house. And so what we're doing is we're stopping, we're cutting or excavating out for the footing. So that means we're cutting away some of the earth. And generally we'd be left with, as you can see here, a little bit of a gap. So do we build up with earth? Well, not really. Instead of building up with the earth, of course, there will be some spoil that we're taking out of the footing. We'll have a few layers that are underneath. So the first layer that goes underneath, that will be directly underneath the slab as we see it, is sand in a typical situation. Now let's pick up the settings of this. So the point of the sand is it's creating a nice soft bedding for the slab. So when the slab is being poured, the sand stops the plastic from being pierced. So we haven't yet represented that, and that will just be represented as a line in a second. And then typically 50 millimeters underneath that, we're then going to have a layer of gravel. So let's find gravel. And typically I will turn off the outline of that just so it looks a little bit cleaner. And then we might have the earth below that level. So we might have a bit of a build up anyway. So that means in terms of the line, if we were to track that through, we may be excavating a little bit of earth from where the slab's going to be for that to work based on the relationship of a 2 brick set down in relationship to our concrete slab. Now we need to have that membrane, so that polythene membrane. This does 2 things. This stops water, because our slab when we pour it is quite liquid. It stops the water from leaching out of the slab into the sand or into the earth. But after the concrete slab is set, it also stops water or damp rising from the earth up into the house. Now a concrete slab can be relatively waterproof, and based on the amount of cement it has, it can be more waterproof, but we can't rely on it alone. And so we will have a membrane. We can represent that membrane just with a dashed line. So I'm going to use my polyline, and I'll change this to be a long dash line or a short dash line. I'll use the short one first and we'll see how that looks. I'm going to trace around basically from ground level around our slab. And I can't see it at the moment because I need to turn on true line weight. Might make that one to 10 just so it's a bit more obvious, and I'll make this a thick line. So we can see that's very thick and it's quite small at 1 to 10. At 1 to 5, that line's even smaller. So we might need to change it from being a short to a long dash line, and that will look a little bit more appropriate. And we could make that very, very thick if we needed to. So we can see that's representing okay. We'll go back to 1 to 10 for now. And that's starting to make a bit more sense based on the screen as you can see it. Now there's another layer that I will typically use that we haven't yet talked about. At the moment, we're allowing for a coupled slab, meaning that we're not creating a thermal break between the slab and the earth. Now this is fairly uncommon for Australian construction, but we're seeing a lot more in European countries and North America. So if we want to create a insulated thermal slab, we need to have insulation underneath our slab. So we'll still probably have the sand and we'll still probably have the gravel, but these might slide down 50 mil. And I might add another layer here for foam. So I'll draw this in. That's a bit funny. Let's try that again. I could just copy it as well. Move, drag a copy, drag it up. And I want foam. I've got a few different types of foam. Insulation rigid is the one that I want. And I typically make the background of this a really light green or really light blue because that's the color of the foam that it normally comes in. So in this case, I'm not talking about standard polystyrene, I'm talking about XPS, extruded polystyrene, which is rigid and hard and able to take the weight of a slab on top of it. And then of course we could even drive a vehicle, such as in a garage, over the top of that, and that would still be okay. Before I go any further, I'm going to get a white fill. And I'm going to place that over the top of this section here. And I'm going to turn the outline off and then display or to bring to front. Because the idea is I don't need to see so much information. I'll end up doing more work if I have to keep on looking at so much information. Now I might use a break line, but at the moment I'm just going to use this white fill as like a ghosting line. And then the same thing here is I don't need to see all of this information. I basically don't need to see anywhere here to here. Again, it's just repetitive. It's not really that detailed or that informative. So I don't need to repeat that information. So I'm really just focused on this relationship and focused on this relationship at the moment. What else do we need to add? So we talked about we have a weep hole here, but how do we get the water to actually go outside? So in a similar way as what we did with this polythene membrane, we're also going to have flashing, which goes under the weep hole and in this case it might go under the bottom plate. So typically this is known as damp-proof course. The idea is that we want water to drain away if it comes inside. There's another layer that we need to add as well, and that's we need to add sarking to the outside of the frame. So we want to have a membrane to try to take any water away that's running or moisture that's inside this wall cavity. So I'll start up top and I'll draw it all the way down. So that's going to be fixed to the outside of the frame, and most importantly, I want it to overlap with our damp-proof course. We also need to add insulation to this wall. Now the insulation, the primary place of this insulation will be in between this wall frame. I can add insulation a few different ways. I can add it as a fill, or I can add it as an object. In ArchiCAD, I prefer to use the object option. It can be a little bit tricky, so we'll rotate it around. And the way that this works is if I grab one edge, I'm changing the angle. And if I grab the other edge, I'm changing the length. So I'll take that back so it's straight. And then if I grab this side, I can change the width. So at the moment, I'm going to grab this and move it into place. Now you see it's already set up to be 90 mil because I use it for this purpose all the time. I don't want to grab this edge because that's going to change the angle. I want to grab this edge and stretch it up all the way so it relates to here. Now I could give it a background color if I want to, but I'm fairly happy with that result. I could change the color of the insulation if I felt that that was beneficial, because of course we won't be seeing through the insulation to the frame. We're going to be seeing the insulation. Now that insulation could be actual wool, or it could be polyester, or it could be some type of a fiberglass insulation. My preference depends on the circumstance. Of course, wool is fantastic. It's natural. Polyester is less itchy. Fiberglass is horrible to use, and of all the fiberglass options, I tend to use something like earth wool because it's the least itchy and supposed to be mostly recycled. Now we can add some type of flooring on top of this. So what is it? It could be tiled, it could be timber, it could be carpet. So in terms of representing this, maybe I'm going to allow for 20 mil of an adhesive, and then 20 mil of tile. So again, like before we talked about, if I end up having a 40 mil build up here, or thereabouts, 38, then we end up having a ceiling height of 2407. Again, at 2400 is the legal minimum. So I have to be very, very careful that whatever finishes that I end up adding don't end up creating a problem with that relationship. We can also see that with only one bottom plate, I'm having a bit of an issue in terms of the tiling, and when that happened in relationship to an interior wall lining, it would be very hard for us to fix that. Now the probability is that I would maybe add plasterboard first and then tile, but that could create problems as well, because if I have plasterboard below floor level, I will end up having moisture coming up into my plasterboard. So what would be a better idea in this circumstance would be to double up and have a double bottom plate. And this is very standard as well. So how does my plasterboard work? My plasterboard is very similar here to what we saw with the sand. The plasterboard will run up. Now in this case, I'm going to have the plasterboard running up past my ceiling batten. We'll change this to be plaster. And I'm having it running down, but I'm not going to have it running all the way to the tile. Typically, I want at least a 10 mil gap at the bottom. The idea is that that's then going to be covered, because the end of a plasterboard isn't very nice. So let's change that, and we're going to make that skirting. So we'll go to the timber detail. I'm just going to make this a very simple representation. So we'll have white, brown. I might make it a little bit thicker brown. And I'll just make this a 90 by 19. So very, very simple. Line that up there, line that up there. And now we're hiding that relationship between the plasterboard and the tile floor. The plasterboard is being fixed into the bottom plate as well as to the studs. The skirting also has been fixed into the bottom plate as well as the studs. Up the top, I want to have a ceiling batten up there. So this is similar to my 45 by 45. So I'm going to copy this down. I'll rotate it. But I don't need it to be 45 by 45, so I'm going to reduce it by 10 mil. I'll temporarily suspend the group, edit, reshape, stretch, and just turn that from a 45 into a 35 quite quickly. And then the idea here is that I have put my plasterboard on first, and then my batten can run up either hard against it or close to it. I might need to multiply this maybe at 600 centers, which means it's probably going to go off the page. Let's do that again. And then I'm going to have plasterboard sitting on top of that. This plasterboard's only going to be 10 mil thick. And I either want this plasterboard to butt into it, or be set off, and then I could do a shadow joint relationship. The shadow joint is going to be a piece of plastic or a piece of steel, preferably.
Well, you kind of put just the G-probe straight to the joist, ceiling joist.
I'm just going to draw this for a sec. It's going to have a little knobbly bit at the end. And the idea is that this plaster angle, so we'll call it a P50. So this steel is perforated here, it gets plastered over, so the relationship between the edge of the plaster looks nice and neat, and then we've got a little bit of a shadow gap where we've got this angle, and it hides the reason why we have this plasterboard against the stud extending up is because I need to hide this relationship. If I didn't have the ceiling batten, so if I was to delete this for a second and move this here all the way to there, I can't extend this plasterboard up any higher than that ceiling joist, which means that relationship there is horrible, and I'm always going to be able to see the edge of that plaster because it's never going to be perfect. In some cases it's going to be ripped and ending up creating little silly joints like that. So by creating a batten that sits under the ceiling joist, so a ceiling batten under the ceiling joist, that allows me to extend up my plasterboard and hide that relationship so I can get a cleaner relationship. The ceiling batten also helps to take out any inconsistencies with the bottom chord of that truss or that ceiling joist in order to make sure that my ceiling is perfectly flat. So that's why I would typically use that level of detail. So that's enough for now. So we've added a bit more detail. We've explained the relationship of the interior lining. We haven't yet done roofing. And we've also explained the relationship of the interior lining in this situation. I'll extend that back. And we've also made this a better quality, more insulated slab. Now we've insulated at the moment only to the underside of the slab. Now if we want to do this really well, we're actually going to add insulation a little bit further as well. So we're going to also add insulation along here. So let's just add this in, 50 mil, and add insulation here, 50 mil, along the inside of this footing. Now, this is getting a bit extreme, and typically we don't even do this in Australia, as in add the foam, let alone add it all the way down the footing. But if we're trying to do this well, that is what we should do, because that's going to give us the most insulated result. We don't want to have the insulation underneath the footing. It's really excessive. Plus, if we have a pier going down here, so of course this earth continues down effectively forever. We have a line. We have a line. And then if I'm trying to represent this well, group those together, make them a bit thicker, and show that as dashed. So we're showing here that there's a concrete pier that extends down underneath the footing, and that extends down as far as we need in order to hit bedrock. I'm not showing the full depth because I don't know. Of course, the really frustrating reality about architectural drawing is that we're trying to imagine what's happening often underground, and then it's not until we've got the approval and construction starts and they start digging that we actually find out how deep we might need to go in order to do those piers. In a typical situation, it would be a lot more efficient if we could drill the holes and then start designing, but of course that doesn't work in that order. So now we've done a lot more of the detail and explaining how this system works, and we can finish off a little bit more later looking at different types of roof systems. At the moment we're allowing for either a tiled roof or a metal clad roof, and then of course we can start adding things like fascias and gutters on the outside of that.